4.4 trigonometric functions of any angle. P is a point 2, -5 on the terminal side of theta. So you're going to graph the point 2, -5, the way you would graph any ordered pair. Then you're going to create a right triangle with the x-axis. Theta is the angle formed by the x-axis. To get radical 29, use the Pythagorean theorem. 2 squared plus 5 squared equals c squared. So 4 plus 25 is 29. Take the square root. I've labeled the quadrants 1, 2, 3, and 4 for reference. The sine is the opposite over the hypotenuse. So it's opposite over hypotenuse. Then you rationalize the denominator, multiplying by radical 29 over radical 29, and that's how I get this. Then you have to ask yourself, for every one of these, is it going to be positive or negative? And that's going to depend on what quadrant you're in. The sine is the y coordinate. Y coordinates in quadrant 4 are always negative because here's where the y-axis is negative. The cosine of theta is the adjacent over hypotenuse. So it would be adjacent over hypotenuse. Rationalize the denominator, multiplying by radical 29 over radical 29, and that's how I get this. Cosine is positive because the x-coordinates are positive in quadrant 4. The tangent is going to be opposite over adjacent. So we have opposite over adjacent, and the tangent is going to be negative because tangent is sine divided by cosine. So if your sine is negative and your cosine is positive, a negative divided by a positive is a negative. The other way you can think about this is looking at the slope of this line. This line has a negative slope, and the tangent is the slope of a line. Cosecant is just the reciprocal of the sine. So take this fraction, flip it, and it also has to be negative because the sine was negative. Secant is the reciprocal of the cosine, so take this fraction, flip it, it's positive. Cotangent is the reciprocal of the tangent. Then you're going to find cosine, sine, and cosecant for quadrantal angles, which are just angles that are on an axis. So if theta is 0 degrees or 0 radians, same thing, that means you're not turning at all. So you're going to start, always start here at 1, 0. You're not going to turn at all. Cosine is the x-coordinate, sine is the y-coordinate. So x, y. The cosecant is undefined because it's the reciprocal of the sine. So it's 1 over 0, which is undefined. A 90-degree turn, which is pi over 2 radians. If you start here, 90 degrees, ends you here. So cosine x, sine y. So cosine x, sine y. Cosecant is the reciprocal of 1, which is 1. 180 degrees, or pi radians, is a half turn. So you end up here. Cosine, sine. So -1, 0, and of course the reciprocal of the sine would be undefined. And then a 270-degree turn, which is equivalent to 3 pi over 2. You start here, turning 270 degrees, lands you here. Cosine, sine. Cosine, sine. And the reciprocal is -1. In example 3, if the sine of theta is negative and the cosine of theta is also negative, name the quadrant in which the angle theta lies. It's going to be quadrant 3, and here's why. This is your y-coordinate is negative. Your x-coordinate is negative, and if you're going negative on the x and negative on the y, you're in this quadrant 1, 2, 3, 4. So it's quadrant 3. If tangent of theta is negative 1/3 and the cosine of theta is negative, you want to find sine and secant of theta. So you first have to figure out what quadrant you are in, 1, 2, 3, or 4. If cosine is negative, then you're either in quadrant 2 or quadrant 3, because here's where the x-axis is negative. Tangent is sine divided by cosine. So to make this negative, you would have to have the sine be positive, because this is sine over cosine, so it has to be a positive over a negative to be a negative. So the y is positive, the sine is positive, but the cosine is negative. So we're in quadrant 2. Now, to figure out what the values are, you're going to make a right triangle. Fill in theta. 1/3 is the opposite over the adjacent. I know that from tangent being TOA, opposite over adjacent. Obviously, I don't put negatives here because they're side lengths of triangles. The negative just tells me what quadrant I'm in. So to get the sine of theta, I want to do the opposite over the hypotenuse, opposite over hypotenuse, rationalize the denominator. And then ask yourself, is it positive or negative? And once again, we said sine would be positive because the y coordinates are positive here. Secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, we're going to do the reverse, which is hypotenuse over adjacent. And the secant will be negative because in quadrant 2, the x coordinates are negative. So if cosine is negative, then secant will be negative. Now, on page 2 of your notes, reference angles. Reference angles are the positive acute angles, and they can be called theta prime, formed by the terminal side of theta and the x-axis. So I've got a drawing here, it almost looks like a bow tie. These angles are reference angles, and that will make more sense once we start doing problems. So we want to find the reference angle, theta prime, for each angle. So a 225-degree angle, I always start here. I turn 180, and then I keep going till I turn 225. So I have a leftover angle of 45. That's my reference angle, because the reference angles are always inside that shape that looks like a bow tie. Theta is 7 pi over 6 radians. This time I'm going to count in radians. So from here to here is pi. If I break it up into 6 parts, I would have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. So I have a leftover pi over 6. That's my reference angle. Negative 210 degrees means I have a clockwise turn. So I start here, I turn 180, and then I've got 30 left over. So my reference angles are always formed with the x-axis, 30 degrees. Now if I say 3.4 is theta, assume that's in radians because I didn't put a degree here. And so if I go pi radians, pi is equal to 3.14. So what's left over between 3.4 and 3.14 would be 0.26. And so your reference angle has to be made with the x-axis.